Hello, welcome to what I hope will be the last video about matrix stuff in this series, Building a Neural Network. So what I want to do is, in this video, is just a little bit of cleanup. I'm working on this toy matrix library in JavaScript that does the math operations I'm going to need for the neural network that I'm going to start building in the next video. But before I get to that next video, I want to clean up a few things and make the library a little better. Again, my goal with this is really educational and for my own amusement in many ways. I'm not trying to create this highly optimized or efficient, comprehensive matrix math library, just a little simple toy library with some key functions that I'm going to need. And as we get later, as I get further and further along, I will eventually replace this with something else that somebody has made, which will be much better. Okay, so what is it that I want to do? I made a little list. I'm checking it just once. It's a list of my favorite things. I'm just trying to reference random songs. Okay, this is the list of things that I want to do. And a lot of these came from comments from viewers, so thank you for those. One is I'm going to add something called static methods to the library. And why am I going to do this? Well, some of the functions that I have currently in the library affect the current matrix object that I call the function on. Matrix.add some number to it. That matrix itself changes when I add a number to all of the elements. But some of the functions in the library actually create a new matrix object and return it. Don't affect the library, the object that the function is being called on. And this is where I want to introduce something called static methods, which will make this more clear. So I'll get into that as I introduce it. I just actually noticed there already is a randomized function in there, but I might want to improve that a little bit, although I'll come back to that later. I want to add something called a map function. And what I want to do with the map function is I want to be able to take any arbitrary function and apply it to every element in the matrix. So if I could write a function that doubles a number, and then I could just apply it to the matrix to double every number in the matrix. That's going to be incredibly useful when I get to that neural network stage. I have to say, hey, compute something like the sigmoid or the tan H, the arctan. There's going to be all sorts of things that I want to do to every element of the matrix. So a generic function called map, like map this function to each number, that's going to be really useful. And then the other thing that I thought of is I do so much console.table the values that if I just make a print function that does that for me, that'll make my life easier and nicer. And programming in many ways, it should be it's more than this, but sometimes it's just about making your life a little bit nicer on a daily basis. Okay, so I'm going to start working on these things. There's a live chat going for the people who happen to be watching this live and not the archive edited version, so maybe I'll get some other suggestions along the way. Okay, so let's first thing that I want to do. I got this comment several times from viewers. This is I did a kind of poor job choosing the name for this variable. So this variable right here, this dot matrix, which is part of a matrix, the matrix class, every matrix object has a matrix variable, is kind of problematic because it has the same name as the name of the class, and this can really confuse people. So one thing I want to do is just change this to data. So a matrix object has a certain number of rows and columns, and the two-dimensional array that stores all the values, that's just the data of the matrix object. So I want to change that. And then there's a fancy, those of you who are watching probably know there's like a fancy way to do this in Atom. Let's see, how do I do it? I always do this by accident, and I can't do it on purpose, where you click on something and it like changes everywhere else it is. Scratch that. I'm going to do it the old-fashioned way, and I'm going to do just a find replace. I'm going to say this dot matrix, replace that with this dot data, because basically everywhere that I'm referring to it by this dot matrix. So let's do that replace all, feel confident about that, and hopefully that's okay. All right, so I've done that. Now, let's move on. What is the thing that I want to do? I want static methods. Okay, so let's look through. This function randomize affects the data of this object. Fine. This function add adds a number or adds another matrix to this particular matrix, changing the values. Done. Transpose, I'm a little confused what to do here with transpose. I'm gonna leave that, I'll come back to it. This is the one, oh boy. This is the one where I really, really need to fix up, because this is such a disaster the way that I've written this function. If I get a matrix, I create a new object and return that object. If I get a single number, I just multiply every value to this object's matrix. So this is kind of a disaster. I've kind of done two wildly different things in the same function. So what I want to do is add a static function. So what do I mean exactly by a static method? So methods are functions that are part of a class, that are attached to objects made from that class, from that template. And so in the case here, what I'm really doing is I'm saying things like, let M be a new matrix. And if I were to say something like m dot multiply 2, this is not a static method. In fact, this is what I think you would refer to as an instance method, maybe. It's a regular function. It's a function that's called on this particular instance of a matrix object. But what if what I wanted to do is say, what if I had two matrices, M and N, and I wanted to create, or M1 and M2, and I wanted to say M3 is, and currently the way the library works right now is I would say M1 dot multiply M2. This is currently the way the library works right now. And it would be fine to keep it this way, but I think what would work better is for me to actually say matrix dot multiply M1, M2. And this is and you've seen this before, right? Anytime in JavaScript when you've done something like math.random or math.sign. These functions are static functions, part of the math object. Oh God, JavaScript, it really drives me crazy, the naming of all these things. But the point is, it's kind of a nice way of namespacing a collection of just utility functions. And so there are some functions in the matrix library that operate on actual instances of matrix objects, and other functions that are just kind of namespaced as part of the matrix world, and you could just put things in them and get things out of them. And that's what I think I want to have this multiply function do. So now I need to look up, I actually have to look up the syntax for static methods in JavaScript because I don't know. I've done this a bunch of times in the Java programming language, but it's probably different in JavaScript. So let me come back over here and let me look up static method JavaScript. And I'm going to type in Mozilla because I like to generally get the Mozilla Foundation documentation. And here we go, static keyword. So it looks like all I need to do, it's very, very simple, is just put the keyword static in front of the function. So if I now, and the real question is, can I have the same function with two names? In other words, am I allowed to have, I basically want to have a static version of multiply that receives two matrices, M1 and M2, and a non-static version that receives a single number that is that actually affects that matrix itself. So what I'm going to do here is I'm going to go and take out all of this math. So this is all of the matrix product math that I worked out in the previous video. And naming-wise, incidentally, I called the two different matrix objects A and B. So in a much simpler way, I can just actually make the argument names A and B, and remember I'm checking if A's columns are not equal to B's rows. Okay, so this should be fine. I'm done. And then here, this multiply function is just the scalar product. All right. Let's see if this works, but before I see if it works, let me actually add this print function. This is not going to be, I'm going to do this on the bottom. I'm going to add a function called print. I could just call it log maybe. Maybe log is a better, no, let's just call it print. And in the print function, I'm going to say console.table this.data, right? So I want to just console table to this.data. So let's take a look. And let's try to manipulate some stuff in the console. So let's say, cannot read property matrix.js line 45 of undefined. So I messed something up. So I had some other places in the code where I was not saying this dot data, but some other matrix dot what now needs to be data. So I can look for anywhere I'm actually saying dot matrix. And here's some other places. And some other places. That's pretty good. Okay, so I took care of that. Let's go back here. All right. Oh, I forgot that I have a sketch that's running that's trying some things out. But let's just say M1 equals a new matrix that is 2 by 2. And I'm going to say M1 randomize, M1.print. Okay, that's the matrix. M1.multiply 2. So I want to double all of those values. And then M1.print, again, M1.print. And we can see, okay, so that's working. My old multiply function, the multiply function that takes a single number and affects every element of that matrix, is working. Now, let's see if the static one works. So now I'm going to say let M2 be a new matrix. And I'm going to say M2.randomize. And M2.print just to check it out. Whoops. Why did that not work? Oh, I didn't give it. So I forgot to give it a number of rows and columns. I should probably add some error handling into the library that says like, hey, you forgot to give me the columns and rows, or use a sub default value. Let's try that again. M2 equals a new matrix. That's also 2 by 2. Let's print it out, and let's randomize it, and let's print it out, and there we go. Okay, so now let M3 equal matrix dot multiply M1 M2. This is now how I want to get a new matrix, which is the result of the dot product, the matrix product between matrix 1 and matrix 2. And if I say M3.print, okay, so I can only assume that the math works correctly. Somebody watching this should feel free to pause and check that math and write in the comments if it's wrong. But what I was really looking for, I checked the math, that the math worked correctly last week. So I'm really looking for now, am I allowed to have two methods, one that's static with a given name and one that's not static with a given name? And it looks like I am, and it makes sense that it would be able to do that because they're called in completely different ways. There's no reason why the computer should ever get confused between the instance, the JavaScript interpreter should ever get confused between the instance version and the static version. As an exercise to the viewer, we can make some arguments whether what's the sort of optimal or most elegant way to write this library, but as an exercise for the viewer, what you could do is take this transpose function and make a static version of it, which is essentially this, right? I was about to do it. Make a static version of this and perhaps leave an instance version which changes the internal data of the matrix object itself to be the transposed matrix. But I'm going to leave that as an exercise for the viewer. So the last thing that I need to do in this particular video is create a map function. That's going to be a function that takes any generic function as an argument. Whoa! So if this is, I think this might be the first time I've really done this in a video in JavaScript. Let's think about this for a second. I can write a function. Let's think about how I'm going to write this. Can I use this eraser? It looks like I can. All right. So I am going to create a function. We got to think about this for a second. So if I were writing a function, and I did this already, called something like add, and it receives a number, right? This is a function I have in my matrix object where what I'm going to do is say plus equal, I'm going to have a whole bunch of for loops. For every element of the matrix, add this number to it. Right? That's what this function does. What I'm saying I want to do is create a function called map. And what that function does is it receives a variable. Maybe I'll call it fn right now for function. Maybe callback it's not really a callback. So it's not a callback. fn for function. And what it's going to do is it's going to execute this function somewhere in the code. And this is something that you can't really easily do in a programming language like Java. You can't make a function a variable that you pass around easily without some like real crazy gymnastics. But this is very native to how JavaScript works. Arguments, we think of them, parameters to a function, we think of them as, oh, send these numbers in or send these other objects in. But a function is a thing that I can send in just as well. So let's look at how this would work. In other words, instead of adding a number to every element of the matrix, I want to apply a function to every element of the matrix. And let's look at how we do that. Okay, so I think the add function, actually we can look here at this is kind of a useful, I'm gonna use this multiply function that instead of add, it just multiplies this number to every element as a starting point. So I'm gonna call this function map as a kind of generic term for mapping a function. And what I'm gonna do is I'm going to say, so I want this same exact apply a function to every element of matrix. And I'm going to say right now, I'm just going to create a variable, let value equal this.data ij. In other words, I want to look through every element of the matrix and I want to take that value. Now this would be me just assigning that element of the matrix its value. What's its value? Assign it. This would not change the matrix at all. But in 2 steps, I pull the value out and I put it back in. But if I have this function, why don't I just apply that function to the value and put it in? So I can execute that function with the value and then assign the result of that function to the data. Make sense? So this might make even more sense once we see how it's used. And this is only going to work if I send in functions that are written in a certain way, but we'll look at that. And maybe somebody watching can let me know, is there a conventional name for what you might call a generic function that's being passed in? I don't want to call it function because that's a reserved keyword. I could call it func. Map that's func. Func. That's good. I like that. Func. Let's change it to func. Okay. All right, so now let's in order to see if I've done this correctly, let me go to sketch.js, which is sort of just a bit of like code that I can use to sort of mess around and see if things are working. Okay, so let me keep, and in fact, this will actually negate the need for certain functions like randomize potentially or add, because I could always create those functions and then call them through the map. But let's look at this. So let's say I have a matrix and I'm going to say a.randomize, and then I'm going to say a.print. So what I want to see is just, and I'll keep this just as a 2x2 matrix, easier to see. So I'm going to refresh this page, and we can see here's my random 2x2 matrix. Now what I want to do is I'm going to write a function called double it, and it takes some arbitrary value, let's call it x, and it returns x times 2. So this is a function, a generic function that receives a value and returns the doubled version of it. So if I say an a.map double it, what this should do is it should send this function double it in through the function map. It's going to receive it here, run through, and now it's saying this.data ij equals double it val. So it's calling the doublet function for every value in the matrix. So let's go back to here, and if I say a.print now, and I run this, we should see, look at this. Here's a matrix with values 2773 or 27, actually, whoa. and now I have 4, 14, 14, 6. All the values are doubled. Great. That worked. I just have to give myself a little, I need a little reassurance every once in a while in the form of bad, lame sound effects. Okay, so I'm being told in the chat that, and this, by the way, is often referred to as a lambda function maybe, but sometimes it is useful to actually use the index values. So So there might be a reason why you want to optionally also pass in the ij, the row column location of each when you're calling the function that's being passed in, because you might want to, you might want to operate on it depending on where it is in the matrix. Like maybe if it's an edge value, you do something different. So in that case, this can be useful. So this is a little bit of an additional advanced thing. I'm going to leave it out of my very simple library, but I thought I should mention that. It's up to you to then, therefore, so I could do something like, as long as I is greater than 0, return x times 2, otherwise return just x. So I could start to do sort of an advanced thing like, I don't want to just do this to everything, but not do something different to the first row. All right, so this brings me to the end of this particular video. I am sure there are things, I'm really sure there are things this matrix class is missing that any comprehensive matrix class would need. And I wouldn't be surprised even if we discover some things we have to change and alter to this as I start building the neural network. But in the next video, what I want to do is return back to this topic of a perceptron. What happens when I have multiple perceptrons, a multi-layered perceptron, and why all of a sudden does this concept of a matrix become so meaningful and important for the math of feed forward. A neural network is actually often referred to as a universal function approximator, right? It receives input, it generates an output. Why do I need matrices inside of that neural network to manipulate how I get the output from the input? That's what I want to look at the next video, the feed forward algorithm. Okay, thank you.